the heart heals. Hi, I'm Mahyar, a researcher from WiTeM laboratory. Electromagnetic radiation and its application are specialized fields in this laboratory. Nowadays, communication and wireless technologies are involved in every aspect of human's life, including telemedicine and implants. One of the projects has done here is development of pacemakers. Today we would like to show you that new pacemakers can be an example of connection between telecommunication and medicine. Let's listen to Dr. Valley talking about pacemakers.
The heart beats rhythmically due to the electrical impulses. These impulses cause the contractions of the atrium and the ventricles, which allow the heart to pump blood. During an arrhythmia, the heart may not be able to pump enough blood to the body. This can cause symptoms such as fatigue, shortness of breath, or fainting. According to Oxford University researchers, near 33.5 million people of the world suffered from arrhythmias in 2010. During an arrhythmia, the heart can beat too fast, too slow, or with an irregular rhythm. A pacemaker is a device which is placed in the chest or abdomen to help control abnormal heart rhythms. This device uses electrical pulses to prompt the heart to beat at a normal rate. Conventional pacemakers have a battery, a computerized generator, and leads which may clog the vein and infections. In addition to these important side effects, the big battery under the skin has a limited lifetime. Thus, patients have to go under minor surgeries regularly, which makes patients uncomfortable and also cause costs for them. Moreover, recent statistics have shown that every 14th patient having a pacemaker device in the chest will develop an infection in the pacemaker pocket, and among these cases, 20% will result in death.
Technology has solved this problem. To overcome disadvantages, researchers have come up with a new type of pacing system with no leads, which is called leadless pacemakers. Leadless pacemakers are placed into the right ventricle of the heart directly. The pacemaker can be charged wirelessly. That's where telecommunications help medical science.
In order to charge the pacemaker's battery wirelessly, we have three different methods. The first one is to use magnetic coupling, which uses coils. The second option is to use capacitive coupling, which needs at least two parallel metallic plates. One should be inside the body and one outside the body. But these two are highly sensitive to distance. The last option, which we have used, is to use RF link, and therefore we need antenna in order to couple power into the body. Now the big question is which frequency band and therefore which antenna size we can use. If we go down to very low frequency bands, then we need very large antennas like this, which is used in FM band. But if we go up to very high frequency bands, then we have another problem. Very high pass loss inside the body. Therefore, we come up with a frequency around 700 megahertz, which is corresponding to half of the wavelength size of around 20 centimeters, like this much. But this is still very large to be implanted inside the body. What we have done in this work is to miniaturize this antenna this much size. The antenna which is going to be placed inside our body should be covered with a biocompatible material, in our case a special type of Teflon. But then this very electrically small antenna should be encapsulated inside this small capsule.
The antenna structure includes ground, substrate, radiating plane spiral shaped, feed pin, and short pin. The whole structure encapsulates in a biocompatible material. The most challenging part is how the antenna works inside the body. We have examined this problem both in simulations and practically. In order to validate the antenna performance, two scenarios employed. The first, inside a phantom which mimics electrical properties of muscle tissue. And the second, inside cow's fat. We hope this project will help humanity.